Welcome to Let's Decode, the place where complex things become crystal clear. It's something we see every day, but few truly understand how it works. Ever wondered what really goes on behind the scenes? Today, we're going to decode it. Simple, clear, and fascinating. What if I told you that we've built a telescope so powerful it can see galaxies that formed just a few 100 million years after the Big Bang? A telescope that can study planets orbiting other stars and even detect what their atmospheres are made of. Welcome to the story of the James Webb Space Telescope, a golden-eyed machine that's changing everything we know about the universe. It all started with the Hubble Space Telescope. Launched in 1990, Hubble gave us breathtaking images and helped determine the age of the universe. But it had limits. It couldn't peer through thick cosmic dust or see the faintest object from the universe's earliest days. Astronomers knew that to go further back in time, they needed to see infrared light, and that required a whole new kind of telescope. In the mid-1990s, NASA and its international partners began working on the next big leap in astronomy. The concept? A telescope 100 times more powerful than Hubble. The James Webb Space Telescope wasn't just big, it was complex. Imagine launching something the size of a tennis court, with a mirror over 21 feet wide, and expecting it to unfold perfectly in space. It had to be folded to fit inside the rocket. It had to operate at temperatures just above absolute zero. And it had to survive over 300 single points of failure. Because of this, the launch was delayed over a dozen times, and its budget ballooned from $500 million to nearly $10 billion. There were moments when the entire mission was nearly canceled. But the dream lived on. On December 25, 2021, aboard an Ariane 5 rocket, JWST finally launched from the European spaceport in French Guiana. Over the next 30 days, as it drifted towards its destination, Lagrange Point 2, 1.5 million kilometers away, it began a complex series of deployments. First, the sun shield unfolded, then the mirrors aligned, and then the instruments cooled down to cryogenic temperatures. In total, it took 6 months to fully commission the telescope. Why is infrared so important? Most of the universe's oldest light has been stretched over billions of years by cosmic expansion. What was once visible light is now infrared. Hubble simply couldn't see it, but JWST can. Infrared also has another superpower. It can see through dust. Many stars and planets form in dusty environments. Using visible light is like trying to look through fog with a flashlight. But infrared acts like a thermal camera. It reveals what's hidden. Thanks to its giant mirror, cold operating temperature, and infrared instruments, JWST can see further and clearer than any telescope before it. Now let's talk discoveries, because JWST didn't just work, it blew minds. JWST found the first deep field. A single image taken in just 12.5 hours revealed thousands of galaxies, some more than 13 billion years old. That's light from the time the first galaxies were just forming. JWST observed WASP 96b, a hot gas giant, and detected water vapor in its atmosphere. It's also looked at planets in the habitable zone, like TRAPPIST-1, searching for conditions suitable for life. JWST found galaxies that were far too large and mature for their age, formed just a few 100 million years after the Big Bang. This is making scientists rethink how fast galaxies could form. JWST found the famous cosmic cliffs and pillars of creation, revealed new stars forming behind thick clouds of dust, now visible for the first time in clear detail. Each discovery is like turning a page in the universe's origin story, and we're still only in the first chapter. But JWST isn't just a camera. It's a tool for answering big questions. What was the universe like right after the Big Bang? How do stars and planets form? Are we alone in the universe? It may even help us detect signs of biosignatures, gases like oxygen, methane, or ozone in alien atmospheres. JWST is also helping map dark matter through gravitational lensing and studying the growth of supermassive black holes, the invisible engines at the heart of galaxies. The James Webb Space Telescope isn't just a machine, it's a legacy, a symbol of curiosity, collaboration, and pushing the limits of human imagination. Over the next decade, it will continue to unveil the secrets of time, space, and existence itself. So next time you look up at the stars, remember, there's a golden mirror a million miles from Earth, quietly watching the beginning of everything. Thanks for watching Let's Decode. If you enjoyed the journey, don't forget to like, share, and subscribe. Stay curious, keep learning, and I'll see you in the next one.